How do you feel about finals?
I feel good. I'm gonna kill it. Get some A pluses this quarter.
Is it me or is it hot in here?
It's getting pretty heated.
Do you get it, dude? Cause heat transfer?
Yes, I get it.
He gets it. Hello friends, welcome to Mr. Sanchez. I study engineering in college, and I wanted to start this video series on tips for studying science classes such as physics and chemistry. This is perfect for whether you're in 4th grade or high school or even in college. We're going to be talking about a universal language that people have been using for thousands of years. This language is called mathematics.
Why are you filming this? For the memories.
Hello! Welcome to our laboratory.
Close to home. Tell us about your project.
We are building particle boards.
Thank you. You too. How do you feel?
Do you have a pencil?
You want to tell YouTube about fugacity?
Fugacity is the most wonderful, magical thing you can learn about.
Fugacity.
He explained it like 10 times, but I only got that one equation.
No, he explained it 30 times, like once per day.
You're right.
Going in. It's week 1. This person and this person are at the library. What kind of reality is this? So math is something that people have developed to make their lives easier. It started with the basics like counting, developed into algebra and even calculus, which engineers use today. You know what they say, without math we are cavemen eating mud. One mathematical tool that people use is called dimensional analysis, which is used in physics and chemistry. And it can be used to calculate things as simple as your weight or your mass, as complex as how much energy is in your car. But it all starts with the basics: mass, length, and time. Can I get some markers, please?
Okay, and these are due back at midnight tonight.
Can I steal the room? Let me go to science video.
Hi YouTube.
What are you doing?
Genetics.
Wow, it's so organized.
I know you told me you love genetics, huh?
Okay, so now I'm going to be introducing the concept of dimensional analysis. We're going to start with the base dimensions, which are mass, length, and time. So each dimension has its corresponding variable. We're going to use lowercase m for mass, and L we're going to use x, y, and z, which I'll explain in the length dimension video, and t, which will be lowercase t. And so each variable has its corresponding units. So if you live in the US, we're going to have American units. You might say, oh, I weigh 130 pounds, which is wrong because American units are idiotic. I don't know why we still have them if the rest of the world is smart and uses SI. But anyway, we're going to talk about that in the next video. Or you might say this glass has 32 ounces, which again, beyond me why ounces is OZ. In SI, this actually makes sense because if you have a small amount of mass, you have something like grams, or a large amount of mass such as kilograms. When you have American units and SI units. So length again is distance, so you're gonna have something like inches or feet, or long distance you're gonna want to use miles, which are very weird units to use. And in SI there's more of a basis because you have something like centimeters, meters, or kilometers, which is a really good base because it's a base of 10. We have 10 fingers. Why not just use a base of 10 in SI units and just drop American units and just switch to SI units already, America? But here lies one of the issues because the dimension is mass, and here we have lowercase m. So another tip is when you're doing dimensions, stick with capital. When you're dealing with units, stick with lowercase. Because this is mass and this is mass, but this meter is not mass, that's meter. So be careful. Just remember, practice makes perfect. So try not to confuse the variable of mass with the units of length. And last is time, where we finally have some consensus and we both agree on both using seconds or hours. So thank you for that, America. But just change everything else, please. Just why? Anyway, mass, length, and time are the base dimensions. And I'm going to introduce mass and length in another video, but time is something that's so easy that it's difficult.
What is time when you think about it? Because, Einstein theorized that time is actually connected. No, he wasn't here on time.
But for now, we're going to ignore the Einsteinian physics and just think about time as a literal sense, such as the time it takes to travel a certain distance, or the time it takes for a ball to fall on the ground, which you'll see in physics. And using these three base dimensions, you can derive other types of principles. So even if you're not interested in science, these types of things are things you see in everyday life, such as speed or velocity, acceleration, force, and energy. So like for example, velocity. Velocity is similar to speed. How fast is something going? Force, how much force does it take for this building to not collapse? For me, that's one of the things I really like about engineering, because it's really useful. And yeah, so you'll go through these videos and we're going to learn how to understand what these really mean. For example, force is mass times acceleration. And acceleration is length per time squared. So the dimensions for force are mass times length per time squared. The reason this is useful is because if you're studying physics and you forget a certain term, you don't really have to memorize anything. That's the beautiful thing about physics and chemistry. There's not a lot of memorizing. It's all about logic. And yeah, we'll be discussing how to derive different types of things. So I really hope this type of thing helps you guys.